I am Larry Hetcher. This is Psych 302, Computer Applications in Data Analysis. And with this video, we're looking at lecture notes, Chapter 070, the chi-square test for independent samples. My usual caution to my students, remember, you do not need to download the data set or perform the analyses described in these notes. You should simply use them as a guide when you complete your exercise, which will involve a different data set. The information needed for the current exercise and the related multiple choice quiz appears on pages 1 through 39 of these lecture notes, which are the pages that I will be reviewing. Let's skip past the basics of this procedure and let's go down to the section headed, I'm on page 2 now. Let's go down to the section headed Illustrative Investigation, Gender and Exercise Status. I think the best way to understand the kind of circumstance when you do chi-square test of independence is to begin with a fictitious example that'll provide us with data for the analysis. Illustrative investigation, gender and exercise status. Purpose of the current investigation is to better understand the types of aerobic exercise activities that are preferred by different demographic groups. Previous research suggests most college students can be classified as falling into one of three categories. A, the non-exercisers who never engage in aerobic exercise at all. B, individual exercisers who engage in activities that provide aerobic exercise but don't require being on an organized team. The individual exercisers are people that do things like jogging and cycling. And finally, C, the team exercisers who participate in vigorous activities that do require being on a team. Team exercisers are people who play basketball or soccer. These three categories constitute a nominal scale variable we will call team and exercise status, or simply exercise status. Research hypothesis. In our investigation, we want to determine whether there are systematic differences between men versus women with respect to types of athletic activities that they prefer. In other words, we want to determine whether team and exercise status is related to participant gender. And by the way, that is the kind of situation where you do a chi-square test of independence. You want to investigate the relationship between two categorical variables. You want to investigate the relationship between two nominal scale variables, a variable that simply indicates which category you're in. Team and exercise status is a nominal scale variable. Participant gender is a nominal scale variable. Based on review of previous research, we predicted the following. Research hypothesis. There will be a relationship between team and exercise status and participant gender in which the percentage of women who are individual exercisers will be larger than the percentage of men who are individual exercisers, while the percentage of men who are team exercisers will be larger than the percentage of women who are team exercisers. Now, if that relationship is kind of difficult to visualize, don't worry, we will see visual representations of it before long. I continue on page 3, research method. Imagine we investigate this research hypothesis. We constructed a questionnaire that consisted of just 2 questions. They were, question 1, when it comes to getting physical exercise, which of the following best describes you? Choose just one response. A participant would either check, I'm a non-exerciser, or they would check, I'm an individual exerciser, and here I have an explanation of what that means. They would check, I'm a team exerciser, and I have an explanation of what that means. Or they might check, none of the above describes me. Separate question, which of the following best describes you? Check just one response. They would check either, I'm a man, or I'm a woman, or neither of the above describes me. So, nominal scale variable, team and exercise status. Nominal scale variable, participant gender. We continue. I'm at the bottom of page 3, moving to page 4. Observed frequencies. We administered this short questionnaire to a large sample of college students. To keep things simple, let's assume that none of the participants had checked none of the above for either of the questions. So let's assume that in looking at our data, no one checked none of the above describes me here. Nobody checked neither of the above describes me. So with our team and exercise status, everybody fell in one of these 3 categories. With participant gender, everybody fell in one of those 2 categories. Page 4. Imagine we obtained usable responses from 238 participants. For each of the subgroups of interest, we computed observed frequencies, that is, the number of people who appeared in that subgroup. Observed frequencies are sometimes called simple frequencies or raw frequencies. Of the participants who self-identified as men, we found that 10 of them were non-exercisers, 41 were individual exercisers, and 34 were team exercisers. What about the women? Of those who self-identified as women, we found that 25 were non-exercisers, 102 were individual exercisers, and 26 were team exercisers. Now pause before we go any further. If I were to ask you, is there a relationship between participant gender and team and exercise status based on the numbers you see here? Most of us would be hard-pressed to answer that question. It's kind of hard to say because there were more women than there were men, and that makes it difficult to compare the frequencies in this group to the frequencies in that group. That's one of the reasons that we're going to compute percentages and plot our percentages in a bar graph. First, we're going to plot them in a cross-tabulation table. I am still on page 4. And we have the cross-tabulation table. Organize the results into a cross-tabulation table, also called a contingency table. Here it says cross-tabulation table, presented observed frequencies for team and exercise status and participant gender. Notice this is a table that has 3 rows running horizontally and 2 columns running up and down. What is this all about? At the bottom of page 4, rows and columns of the table. When the time comes to analyze our data, we have to be clear in our minds as to which of the 2 variables is the row variable and which is the column variable. Continuing on page 5. In the preceding table, the row variable is team and exercise status. The body of the table consists of 3 horizontal rows with 1 row for each of the following categories. The row variable is team and exercise status, because our 3 horizontal rows are the 3 categories under that variable. 1 row represents non-exercisers, 1 represents individual exercisers, 1 represents the team exercisers. So the row variable is team and exercise status. It goes on to say, in the same table, the column variable is gender. Table consists of 2 vertical columns, 1 column for each of the 2 categories. In the same table, column variable is gender. One of the vertical columns represents men, one of the vertical columns represents women. I'm continuing now on page 5. I'm sort of in the middle of page 5. Cells in the table. In this cross-tabulation table, a cell is a location where a horizontal row intersects with the vertical column. Preceding table consists of 6 cells. For example, at the spot where the row for non-exercisers intersects with the column for men, the cell contains the value 10. That indicates that 10 of the men were non-exercisers. What is this about? This is a cell. This is a cell where the row-headed non-exercisers intersects with the row-headed men. Apparently, there were 10 men who were non-exercisers. There were 41 men who were individual exercisers, and so forth. There were 25 women who were non-exercisers, 102 women who were individual exercisers, and so forth. Returning to page 5, I'm at the bottom of page 5, well, sort of in the middle of page 5. Bar plot illustrating the results. These results will be easier to understand if we convert the observed frequencies into percentages and then present these percentages in a clustered bar plot such as the one presented below. We continue to page 6. Here's our clustered bar plot, which makes the percentages a little bit easier to understand. The text below describes the plot. The legend in our table, which is this bit, the legend indicates that the blue bars represent participants who identified as men, orange bars represent participants who identified as women. So blue bars represent the men, orange bars represent the women. Horizontal x-axis of the plot is headed team and exercise status. First tick mark on the left side is headed non, and above the bars, and the bars above this tick mark represent results for the people who said they were non-exercisers. So the x-axis, horizontal x-axis, is team and exercise status. Above the heading non, we have the non-exercisers. Above the heading individual, we have the individual exercisers. And above the heading team, we have the team exercisers. And I'll bet the rest of the paragraph just puts in the black and white the things that I just said. Yes, individual exercisers, team exercisers, and so forth. Let's continue. I am still on page 6. We come to this, understanding percentages within gender. The vertical y-axis on the left side of the plot is headed percentages within gender. This label indicates that the bars for a given gender provide percentages within that gender. What is he talking about? Here's the y-axis, vertical y-axis. It is headed percentages within gender. Now, what are we saying? The label indicates that the bars for a given gender provide percentages within that gender. If we added together the percentages represented by the 3 blue bars, these percentages would sum to 100%. The blue bars represent the men. If I took this percentage represented by this one blue bar, added to it percentage represented by this blue bar, and added to it percentage represented by this blue bar, they would sum to 100%. By the same token, the orange bars represent women. If I took the percentage represented by this bar, orange bar, added to it percentage represented by this orange bar, and I added to it percentage represented by this orange bar, they would sum to 100% as well. That's what we mean when we say percentages within gender. And the rest of this paragraph just puts in the black and white the words that I just spoke. I'm still at the bottom of page 6. General trend of the results. Preceding plot makes it much easier to understand the results that appeared in the contingency table presented earlier. Specifically, the plot shows the following. When we compare the 2 bars that appear above the heading non, there does not appear to be much difference between the percentage of men versus percentage of women who describe themselves as being non-exercisers. Above the heading non, there's not much difference between the percentage of men who said they're non-exercisers versus the percentage of women who said they're non-exercisers. The bar is a little bit taller for women, but there's not a big difference there. Let's continue. I'm at the top of page 7 now. When we compare the 2 bars that appear above the label individual, it looks like the women were more likely to be individual exercisers compared to the men. Go to the figure. Yes, the percentage of women who said that they are individual exercisers appears to be substantially larger than the percentage of men who said that they are individual exercisers. Well, what about the team exercisers? Finally, when we compare the 2 bars that appear above the heading team, it looks like the men were more likely to be team exercisers compared to the women. Is that true? Look at the 2 bars above the heading team, and yeah, the percentage of men who said that they are team exercisers looks like it's bigger than the percentage of women who said that they are team exercisers. So there does seem to be some differences between men versus women with respect to what kind of exerciser they say they are. Continuing on page 7. To summarize, most of the results illustrated in the bar plot are consistent with our research hypothesis. In other words, it looks like there probably is a relationship between gender and exercise status. But this is merely based on a visual review of the percentages. Is the relationship between the 2 variables strong enough for us to describe it as being statistically significant? Does the strength of the relationship represent a small effect? Does it represent a large effect, something else? To answer these questions, we have to analyze the preceding data using Jamovi. So far, we've just kind of eyeballed the results. We're speculating. Is it substantial enough that we can call it statistically significant and a large effect, for example? Jamovi will answer those questions. I'm on page 7, halfway down page 7. Starting Jamovi and creating the data set. Starting the application. The way you start Jamovi depends on whether you're using the installed version or the online version. By this point, you've decided which of those approaches you're using, so go ahead and start Jamovi regardless of which approach you're using. Once you've started up Jamovi, you get the usual Jamovi interface, which looks something like this. Right now, it doesn't have any data. We're not going to download a data set. Instead, we're going to create a data set and add the numbers we need right into this Jamovi spreadsheet. So on page 8, creating your Jamovi data file, rows and columns of the Jamovi data set. You will now create Jamovi data set, which will contain the observed frequencies that were presented in the preceding cross-tabulation table, although we have to reorganize the table a bit. To refresh your memory, that cross-tabulation table is presented again below. This is exactly the same cross-tabulation table that we saw earlier with the observed frequencies in each cell. At the bottom of page 8, we are going to learn how to create a similar version of the Jamovi dataset that can be used to perform chi-square test of independence. With this type of data set, each cell in the preceding cross-tabulation table will be represented by one of the horizontal rows in the Jamovi table. The number of rows in this data set will be equal to the number of cells in the cross-tabulation table. And since the current cross-tabulation table has 6 cells, this means the Jamovi data set will have 6 rows. What is he saying? Well, this is our cross-tabulation table. How many cells do we have? 1, 2, 3, 4, 5, 6. We have 6 cells in this table, and that means that our Jamovi spreadsheet is going to have 6 lines of data. I continue on page 9. I'm near the top of page 9. Jamovi dataset will consist of 3 vertical columns, and this is what the 3 vertical columns will be about. First column will be a categorical variable that codes team and exercise status. Specifically, it'll identify the non-exercisers versus the individual exercisers versus the team exercisers. The second vertical column in our spreadsheet will be a categorical variable that codes participant gender. Specifically, it'll identify the people who self-identified as men versus women. Third column will be a continuous quantitative variable which indicates frequencies, the number of people who appeared in each of the 6 cells of our cross-tabulation table. We begin by creating a variable that codes whether a person is a non-exerciser versus an individual exerciser versus a team exerciser. We use the value 1 to represent participants who are non-exercisers, 2 to represent the individual exercisers, and 3 to represent the team exercisers. To begin this process, just type the values 1, 2, 3, 1, 2, 3 in column A of the Jamovi dataset as illustrated below. This is a simple step. In column A, type 1, 2, 3, 1, 2, 3. Don't worry, we will do something with those numbers. We'll now assign a name to the first categorical variable, and we'll indicate which category is represented by the values 1, 2, and 3 respectively. To do this, double-click the top of the column headed A. This will open the data variable panel for this variable as shown below. Double-click the top of the column headed A. Just put your arrow pointer in this spot and double-click, and it opens up the data variable panel for variable A. We can now assign a name to this variable and tell Jamovi what names we want to give to the different values. Let's see what we have highlighted. In this data variable panel, the first empty box contains the name of the variable, which at this point is simply A. Click inside this box and replace this name with the name team and exercise status. By default, Jamovi gives your first variable the name A. You're going to click this A and replace it with the name team and exercise status. In the same panel, the box headed levels, which is this largish box, the box headed levels contains the numbers that we have typed into the first column, 1, 2, and 3. We'll replace these numbers with meaningful labels for each of the categories. Do the following. In the box headed levels, replace the number 1 with non. Replace 2 with individual. Replace the number 3 with team. And that means here, I'm going to replace this 1 with non, 2 with individual, 3 with team. I'm not done. I'm still working on this data variable panel. In the same data variable panel, verify that measure type is identified as nominal, which it probably was as default. Measure type should be nominal. If you don't have the word nominal there, click the drop menu and change it to nominal. In the same data variable panel, verify that data type is integer. To the right of data type, make sure that it's integer. If necessary, click the arrow, open up the menu, and change it to integer. When finished, this data variable panel should resemble the one appearing below. This is what your finished data variable panel for variable A should look like. The new name for this variable is team and exercise status. Its measure type is nominal. Its data type is integer. Number 1 represents non-exercisers. Number 2 represents individual exercisers. Number 3 represents team exercisers. When everything appears to be correct, click the up arrow right here icon to close this data variable panel. You can now see that the numbers that you had typed into the first column have now been replaced with appropriate labels for the 3 categories of team and exercise status variable. What's he saying? Click this up arrow and it will reveal your spreadsheet. If necessary, you can scroll up and reveal all of the rows of this spreadsheet. And yeah, sure enough, things that had previously been identified with 1 are now identified as non. 2 is now identified as individual and so forth. So we have non-individual team, non-individual team. That is our first column and our first variable. We'll now create a new categorical variable that'll code participant gender. We'll begin by using the number 1 to represent participants who self-identified as men, and we'll use the number 2 to identify participants who self-identified as women. So in the column headed B, type the number 1 on the first 3 lines and type the number 2 on the next 3 lines. The data set should look like the following. Variable B is where we are. We type 111. 222, and don't worry, we will replace those numbers. We'll now open the data variable panel for column B, and we'll assign meaningful name to this variable, assign meaningful labels to the 2 levels. To begin this process, double-click the top of the column headed B to open its data variable panel. The open panel should look like this. Once again, this is the top of column B. Double-click this place, and the data variable panel opens up. It initially looks like this. In this data variable panel, click inside the box that contains the current variable name, which is currently B, and replace it with the name of the variable gender. So click this if necessary and make the variable name gender instead of simply B. We'll now replace the value 1 and the value 2, which currently appears in the levels box, with appropriate labels for these categories. In the levels box, click the value 1 and replace it with the label men. Click the value 2 and replace it with the label women. So click this 1, replace it with men. Click this 2, replace it with women. Verify the measure type is still nominal. It probably was that from the beginning. If necessary, change this to nominal. And verify the data type is integer. It probably started off integer. If necessary, click this menu and change it to integer. When finished, your data variable panel should look like the following. I'm on page 14 now. This is your data variable panel for the second column. The name is gender. It's a nominal scale variable. The data type is integer. The value 1 represents men. The value 2 represents women. When everything appears to be correct, click the up arrow icon, this icon, to close the data variable panel. When you do this, your Jamovi data set should resemble the one below. Again, you might have to scroll on this spreadsheet in order to reveal all the rows, but when you reveal all the rows, now the first 3 rows represent men, the last 3 rows represent women. Okay, we've got our first 2 variables created. What about frequencies? The third column of this data set, the column that's currently headed C, will be used to indicate the frequencies of the observations that appeared in each of the 6 cells of the cross-tabulation table. We move to page 15, toward the top of page 15. We will use this last column to indicate how many of the participants were non-exercisers and were also men, how many were individual exercisers and were also men, and so forth. To begin this process, double-click the top of the column headed C to open the data variable panel for this column. The resulting panel should look like this. Double-click at the top of C and you open up the data variable panel for the C variable. Continuing, I'm still on page 15. In this data variable panel, do the following. Top box in the panel contains the name of the variable, which is currently C. Click this name and replace it with a more meaningful name, frequency. Change this C to the word frequency. To the right of the heading measure type, click current value, reveal the drop-down menu, and from the resulting item, select continuous. So click this down arrow and change the measure type from nominal to continuous. Verify that the section headed data type displays integer. Data type should be integer. If it isn't integer, click this arrow and select integer from the resulting menu. Notice we don't need to do anything with levels here. Levels appear in this levels box only if it's a nominal or ordinal scale variable. In this case, we've told Jamovi that it's going to be ultimately it is going to be a continuous variable. Therefore, there aren't going to be any levels there. So let's see, before I get ahead of myself, where was I? The right heading measure type, select continuous, verify that the section headed data type displays integer. Okay, now, when completed, data variable panel should look like the following. I am on page 16. This variable we're going to call frequency. Measure type, it's continuous. Data type, it's integer. There are no levels here. We don't need to change anything here. Instead, we're going to add frequencies into the column itself. I am still on page 16, halfway down. When everything appears to be correct, click the up arrow and close your data variable panel, and the resulting data set should now look like this. So once you're satisfied that your frequency variable is correct, click the up arrow, and if necessary, scroll in the spreadsheet so you can see this new frequency column you've created. The variable called frequency is continuous. We know that because there's a little ruler next to its name. It's empty, but we're going to add numbers to this column. Continue on page 17. In creating our data set, our last task is to type the appropriate values into this column headed frequency. To do this, we'll simply take the values that had appeared in the cross-tabulation table presented earlier, and we will type them into the appropriate location in the Jamovi data set. Now, here's cross-tabulation table presented earlier. We're going to take these frequencies from these cells and insert them in the appropriate row in our Jamovi data set. In the Jamovi data set we just created, the first row has the value non under the heading team and exercise status, and has the value men under gender. Now, hang on, is that true? Yeah, under team and exercise status it says non, and under gender it says men. So what number am I supposed to type in here? Let's continue. This means that in this column, in the column headed frequency, we should indicate the number of participants who were both non-exercisers and men. Our cross-tabulation table indicates that there were 10 participants who appeared in this cell. Therefore, we'll type the value 10 in the Jamovi data set below the heading frequency. We use a similar logic to decide the value to type in the frequency column for each of the remaining rows. So rather than reading all this text, row 1, under team and exercise status, it's the non-exercisers, and under gender, it's men. So what's the frequency of people who were non-exercisers and also men? We need to check our cross-tabulation table before. Okay, non-exercisers and also men, there were 10 of them. That is why I typed 10 in this spot. The next row, individual exercisers and also men. What number should I type? Individual exercisers and also men. There were 41 of them. So I typed 41 in this spot. Team exercisers and also men. There were 34 of them. So I typed 34 in this spot. Non-exercisers and also women. Let's see. Non-exercisers and also women. There were 25 of them. So I typed 25 in this spot, and so forth. Using that logic, I transferred the frequencies from the cross-tabulation table above into the appropriate spot in this column-headed frequency in my Jamovi data set. I now have a Jamovi data set. Now, that's all that I need to do in creating the data set. I'm now free to request whatever kinds of statistical analyses I want. So, still on page 18, we come to the section Performing the Analysis in Jamovi. With the data set complete, we can turn our attention to performing the necessary data analysis. First up, requesting the contingency table and chi-square test. Near the top of the Jamovi interface, select the Analysis tab if necessary, then select Frequencies, and from the resulting menu, select Independent Samples Chi-square Test of Association. This is all illustrated in the screen capture below. Now, this is my Jamovi interface that I had been working with. If necessary, click Analyses to reveal the Analyses ribbon. From the Analyses ribbon, click the icon headed Frequencies. That produces a drop-down menu. And from the resulting drop-down menu, select the item headed Independent Samples Chi-square Test of Association. That is the independent samples chi-square test that this chapter is all about. So when you select that, it should open up the analysis options panel for the independent samples chi-square test. That's what the text says. This will open the analysis panel for the chi-square test association. Remember, we're calling it chi-square test of independence. And the initial version of the analysis option panel looks like this. Notice it is headed contingency tables. That's because the first thing you have to do is tell Jamovi how to create the contingency table that you want. So at the bottom of page 19, we have this. In your initial panel, the list of variables in the data set appears in the large box on the left side of the contingency tables panel. So here's my list of variables. I'm going to do something with at least some of these variables. To begin the analysis, do the following. Move the variable team and exercise status into the box headed rows on the right side of the panel. Take team and exercise status and move it into the box headed rows. Take the variable gender and move it into the box headed columns. So take gender, move it into columns, and move the variable frequency into the box headed counts. Take the variable frequency and move it into the box headed counts. When finished, upper part of the Jamovi analysis options panel should look like this. Rows represented by team and exercise status, column represented by gender, counts is represented by the variable that I call frequency. Page 20, halfway down. Which variable was the row variable versus the column variable? It's no accident that we enter the variable names in the order that appears in the preceding capture. In the preceding screen capture, the fact that the variable team and exercise status appears in the box-headed rows means that the row variable in the contingency table that Jamovi will create will be team and exercise status. One of the rows will provide observed frequencies for non-exercisers. One row will present frequencies for individual exercisers and so forth. The fact that the variable gender appears in the box-headed columns means that the column variable in the contingency table that Jamovi creates will be gender. One of the columns will provide observed frequencies for men, and one of the vertical columns will provide frequencies for women. In other words, the contingency table that appears in Jamovi results panel will have the same basic layout as the original cross-tabulation table we began with. In most cases, it's easiest if we ask Jamovi to create a contingency table that's laid out in the same way that our original table had been laid out. Among other things, it makes it easier to check your numbers and make sure that you input your numbers correctly. As soon as you move these variables into the appropriate boxes in the upper part of the Jamovi analysis panel, the contingency table will appear in the results panel on the right side of the Jamovi interface. It is reproduced below. This is the contingency table created by Jamovi. Notice this should look familiar. The rows are non and individual and team. The columns are men and women. That makes it easy to check things. Verifying that the data were keyed correctly. This is a good time to verify that the frequencies that appear in the 6 cells of your contingency table created by Jamovi match the frequencies in the 6 cells of the cross-tabulation table that this chapter started with. Let's reproduce that original cross-tabulation table again below. This is the cross-tabulation table we began with. There were 10 men who were non-exercisers and 41 men who were individual exercisers. And sure enough, that's what Jamovi thinks too. 10 men were non-exercisers, 41 men were individual exercisers. Check all of these numbers against the numbers you started with. Make sure that things match. No problems so far. We continue on page 22, toward the bottom of page 22. Options to request in the statistics panel. It's time to request some specific statistics needed for our analysis. In the bottom half of the contingency tables analysis panel, click the arrow to the left of the heading Statistics to reveal our options for the statistics we may request. There, do the following. In the section headed Tests, verify that the box heading chi-square is checked. This will request the chi-square test of independence that we need. In the section headed Hypothesis, verify that the radio button for Group 1 is not equal to Group 2 is checked. In the section headed Nominal, check the box headed Phi and Kramer's V. This will cause Jamovi to provide Kramer's V statistic, which is the index of effect size for the analysis. When finished, that section of the panel should look like this. Now, to back up a bit, this is the same Jamovi analysis options panel that we talked about before. In the boxes up above, we told Jamovi which variable was going to be the row variable, which would be the column variable, and so forth. We now want to request statistics. If necessary, click this down arrow to reveal all of the options available in the statistics panel. Check the options that I have checked here, and those are the statistics and statistical options that we want for our analysis. We continue. Options to request in the cells panel. I'm here toward the bottom of page 23. Next up, click the arrow to the left of the heading Cells to reveal the options in that section of the analysis panel. There, in the section headed Counts, check the boxes for observed counts, expected counts. In the section headed Percentages, check the box headed Column. When finished, this section of the analysis panel will look like this. We're still in the same analysis panel we started with. If necessary, click this arrow to reveal the options available for cells. Check all the options that I have checked here, and we have requested the cells options we need. Let's continue to page 24. Options to request in the Plots panel. In the Analysis panel, now click the arrow to the left of the heading Plots to reveal the options that are available. Then do the following. In the section below the heading Plots, check the box for Bar Plot. In the section headed Bar Type, verify the radio button headed side by side is selected. In the section headed Y-axis, select the radio button headed Percentages. To the right of this heading, click the drop-down menu and select Within Column. In the section headed X-axis, verify that the radio button for Rows is selected. When finished, the Plot section of the analysis panel should look like this. Again, we're in the same analysis options panel we've been in for the past many minutes. Click this arrow if necessary to reveal the Plots options. Check the things that I have checked here. To the right of percentages, make sure you've selected within column. We have now requested the plots that we want. We can now turn to reviewing the results we have produced. At the bottom, page 24, reviewing the results produced by Jamovi. Don't forget, add your name to the Jamovi results panel, as I often require in my assignments. I clicked on the heading results that appeared at the top of the Jamovi results panel. This caused Jamovi to provide me with a new blank line below that heading. I clicked results and it created a little empty line below it. And I typed my name, Larry Hatcher, in that blank line. When I save the Jamovi file later and reopen it, my name will still be in that location. So if you're a student of mine, yes, do type your name in that location when you ultimately complete one of the exercises for my course. Let's continue. Bottom of page 25, checking assumptions. There's a number of assumptions that should be satisfied so that the chi-square test will give you correct results. We're going to focus on just one of them, the one that is most likely to go wrong and the one you need to worry about. Before we review the results of the null hypothesis significance test, we will first verify that we've met the assumptions underlying chi-square test of independence. One of the assumptions is independence of observations. We're not going to worry about that at this moment. The one we will worry about is this, expected frequencies. The term expected frequencies refers to the number of observations that would be expected to appear in a given cell if the null hypothesis were true. That is, if there was no relationship between the two variables in the population. In tables with more than 2 rows or more than 2 columns, here's our requirement. No more than 20% of the cells should have expected frequencies less than 5. And none of them should have expected frequencies less than 1. In short, it is generally bad if you have expected frequencies less than 5. So we're going to request expected frequencies and make sure that we don't have more than we should have. Expected frequencies for the current analysis can be found in the contingency table created by Jamovi. This table appeared within the results panel of the Jamovi interface and is reproduced below. Notice one of the rows in this table is headed expected. We had requested that when we performed the analysis. In the preceding contingency table, the values that we need appear to the right of the heading expected. The table shows the following. Expected frequencies for participants who were non-exercisers and were also men is 12.50. Okay. Expected frequencies of people who were non-exercisers, you can tell from the non, and were also men, you can tell from the heading men, was 12.50. That's good. That's bigger than 5. We want things to be bigger than 5. Expected frequencies for those who were individual exercisers and were also men was 51.07. Okay. Expected frequencies, if you're an individual exerciser and also men, expected frequencies was 51.07. That's bigger than 5. We want things to be bigger than 5. And so forth. You can interpret each of the expected frequencies for each of the 6 cells in that fashion. None of the preceding cells had an expected frequency less than 5, and that means that our data satisfies the assumption involving expected frequencies. So good, no problems there. Let's continue. I'm still on page 27. Having satisfied ourselves that there's no obvious violations of assumptions, we can move on to interpreting the results. General trend of the results. Our research hypothesis for the current investigation is that the variable team and exercise status will be related to the variable participant gender. Specifically, we predicted that percentage of women who are individual exercisers will be larger than the percentage of men who are individual exercisers, and the percentage of men who are team exercisers will be larger than the percentage of women who are team exercisers. Column percentages in the contingency table. One way to determine whether our obtained results are consistent with our predictions is to review the contingency table that was produced by Jamovi. It is reproduced below. In the section headed contingency tables, I have added this dashed line oval. What do I have to say about this? In the preceding contingency table, statistics that will be most useful in understanding general trend are the column percentages, values that appear to the right of a heading, percentage within column. So we care about the values to the right of the heading, percentage within column. To make them easier to identify, dotted line oval has been drawn around the column percentages for each of the three categories of team and exercise status. Let's see why these values are called column percentages. Focus on just the column percentage values that appear in the vertical column headed men. Let's scroll down a little bit so we can see the text in the table as well. Focus on the column percentage values that appear in the vertical column headed men. That is this vertical column. These values show that 12% of the men were non-exercisers, 48% of the men were individual exercisers, and 40% of the men were team exercisers. If we add these values together, we see that they sum to 100%, confirming that they are indeed column percentages. Okay, under men, we see 12% of the men were non-exercisers, 48% of the men were individual exercisers, 40% of the men were team exercisers. If you add those three percentages together, they sum to 100%. Same thing is going to be true if we focus on the column percentages that appear in the vertical column headed women. These values show that 16% of the women were non-exercisers, 67% were individual exercisers, 17 were team exercisers. These values also sum to 100%, confirming they are also column percentages. Focus on the column-headed women. 16% of the women were non-exercisers, 67% were individual exercisers, and so forth. These three percentages sum to 100%. So yeah, we were looking at column percentages. We'll now review these same column percentages, but from a different perspective. We'll review them separately for each of the three categories of the team and exercise status variable. This reveals the following. About 16% of the women indicated that they were non-exercisers, while a slightly smaller percentage of the men, 12%, indicated that they were non-exercisers. What is he saying? 16% of the women said that they were non-exercisers, and a slightly smaller percentage of the men, 12%, said that they were non-exercisers. Not much difference between men and women when it comes to being non-exercisers. But about 67% of the women said that they were individual exercisers, while a smaller percentage of the men, 48% of the men, identified themselves that way. So 67% of the women said that they were individual exercisers, and a substantially smaller percent, 48% of the men, said that they were individual exercisers. So this is a difference. It looks like the women were more likely to say they were individual exercisers compared to the men. I wonder if there'll be a similar difference when we look at the team exercisers. At the top of page 29, around 40% of the men said that they were team exercisers, while a smaller percentage of the women, 17%, identified themselves that way. Is that true? 40% of the men said that they were team exercisers, but a much smaller percentage, 17% of the women, said they were team exercisers. So there's a difference between men and women when it comes to being a team exerciser, apparently. Continuing on page 29, of the preceding bullet points, the last two were most relevant to our research hypothesis. In both cases, the general trend was consistent with our predictions. Well, numbers are kind of difficult for us to think about, being the human beings that we are. Isn't it possible to illustrate this in a bar chart? It is. At the top of page 29, percentages illustrated in a bar chart. Tables like preceding contingency table can be challenging to interpret. Easier way to understand the general trend of the results is to review the bar plot that we requested in our analysis. This is where our bar plot comes in. Okay, we have a bar plot where the horizontal x-axis is team and exercise status. The legend tells us that the blue bars represent men, the orange bars represent women, and the vertical y-axis is headed percentages within gender. What do we have to say about this? The plot shows the following. Percentages for the participants who describe themselves as being non-exercisers are illustrated by the two bars above the label non in the figure. He's referring to these two bars. Bar representing women was slightly taller than the bar representing men, indicating percent of women describing themselves as being non-exercisers was slightly larger than the percentage of men who described themselves this way. So women somewhat more likely to say they're non-exercisers, but not a big difference there. What about this set of bars above the heading individual? Our next bullet point refers to that, and this is at the top of page 30. Percentage of participants describing themselves as being individual exercisers appear above the label individual in the graph. It shows percentage of women describing themselves as being individual exercisers was larger than the percentage of men who describe themselves this way. And yeah, women more likely to be individual exercisers compared to men. Third bullet point. Finally, the bars on the right side of the plot show the percentage of men who describe themselves as being team exercisers was larger than the percentage of women who describe themselves that way. And yeah, our third set of bars. Men were more likely to say that they were team exercisers compared to women. To summarize, general trend of the results is consistent with our predictions. So we've got the trend that we had hoped for, but right now we're just eyeballing the results. Because we have the trend doesn't mean that the relationship is statistically significant, and that's where Jamovi comes in again. I'm on page 30, about halfway down page 30, the null hypothesis significance test. It turns out that the generic statistical null hypothesis for a chi-square test of independence is fairly simple. It states the following. In the population, there's no relationship between the two variables. Well, let's get more specific. In our current investigation, the two variables being studied were team and exercise status and participant gender. Therefore, we can restate our statistical null hypothesis to be a little bit more specific by stating it this way. In the population, there's no relationship between team and exercise status and participant gender. Remember, statistical null hypothesis is the one that we, the researchers, usually hope to reject. The no effect value for chi-square statistic itself is 0. In other words, when there's no relationship between the two variables, chi-square statistic itself should be equal to 0 or pretty close to 0. As the strength of the relationship between the two variables becomes stronger, chi-square statistic becomes a larger and larger positive value. Chi-square is always a positive value, unlike some other statistics we've studied. Let's continue to page 31. Now, the chi-square statistic is one thing, but what we really care about is the probability value associated with that chi-square statistic. That is the p-value for the chi-square statistic. If the p-value for the obtained chi-square statistic is less than the alpha criterion we've selected, typically 0.05, researcher rejects the null hypothesis and concludes that there's a significant relationship between the two variables. Well, let's see what we have with our analysis. When we performed the current analysis with Jamovi, we requested the chi-square test of independence. In the Jamovi results panel, the resulting statistics appear in the table headed chi-square test. That table is reproduced again below. In the preceding table, at the location where the row-headed chi-square intersects with column-headed value, we can see that the obtained value of chi-square is 15.34. So the row-headed chi-square intersects with a column-headed value. My obtained value for chi-square statistic is 15.34. Below the heading degrees DF for degrees freedom, we can see degrees freedom for this chi-square statistic was 2. And finally, below the heading P, we can see the obtained probability value associated with this chi-square statistic is less than 0.001. My p-value is smaller than 0.001. That's good news for me. Combined, this indicates the following. My obtained value of chi-square was 15.34. That's larger than the value of 0, which would have been expected if the null hypothesis were true. If the null hypothesis were true, probability we would obtain a chi-square statistic as big as 15.34 is pretty small. In fact, it's less than 0.001. My obtained p-value is smaller than the alpha criterion I had selected before analyzing the data. We had selected an alpha level equal to 0.05, and my obtained p-value is less than 0.05. Therefore, we reject the null hypothesis. We can tell the world that the relationship between team and exercise status and participant gender is statistically significant. So good news for us. My chi-square statistic's 15.34. P-value is teeny. It's less than 0.01. I can reject the null hypothesis. I've got statistically significant results. I'm on page 32 now. Now, just because my results are statistically significant does not necessarily mean there's a strong relationship between the two variables. To determine that, I need to review my index of effect size. Kramer's V, sometimes represented as Kramer's phi or Kramer's phi with a C subscript, is an omnibus index of effect size that reflects overall strength of the relationship between two nominal scale variables. It can be used with contingency tables that contain any number of rows and any number of columns. 2x2 tables, 2x3 tables, 3x5 tables, or even larger. Kramer's V ranges in size from 0 to +1. The no effect value is 0, and larger values indicate stronger relationships. Kramer's V for the current analysis. The index itself was provided in the Jamovi results panel in the table headed nominal. That table is reproduced again below. I'm on page 33. We have a table headed nominal. To the right of the heading Kramer's V, we see this value, 0.25. Excuse me. Table shows for the current analysis, the obtained value of Kramer's V was 0.25. Okay, good, but what does that mean? Is it weak effect? Is it strong effect? To interpret the size of Kramer's V obtained in a given investigation, it is best to compare it against the size of the values that were obtained in previous investigations of the same variables. When this is not possible, many researchers compare it to benchmarks suggested by Cohen. Table 2 provides these benchmarks. Table 2, Cohen's benchmarks for interpreting effect indices computed from contingency tables. Notice that this looks semi-complicated. Apparently, there's different benchmarks for labeling something a small effect or a medium effect. How do we know which of these rows of benchmarks applies to us? I'm on page 34, halfway down page 34. Table shows that the values of V that represent small, medium, and large effects are determined by the number of rows and columns in the table. To use these criteria, we must first determine the value of K, that's lowercase k for a contingency table. The value of K will either be the number of rows or the number of columns in the table, whichever is smaller. For example, with a 2x2 table, K is equal to 2. With a 2x3 table, K is still equal to 2. With a 3x4 table, K is now equal to 3, and so forth. Once we've determined K, we can locate the row of the table that provides Cohen's criteria for interpreting V. In our current analysis, our contingency table consisted of 3 rows and 2 columns. Smaller of these two values was 2, and that means that K is equal to 2 for this analysis. Cohen's benchmarks provided in the preceding table indicate that we should therefore interpret our obtained value of V as being a small effect if it's greater than 0.100 as a medium effect if it's bigger than 0.300, or a large effect if it's bigger than 0.500. Now, hang on, where did this come from? What is K in our study? K is equal to 2. How come? Well, our table had two rows. No, it had 2 columns and 3 rows, 2 and 3. The smaller of these two values is 2, and that means K is equal to 2 for our analysis. When K is equal to 2, we use these benchmarks. Call it a small effect if V is bigger than 0.100. Call it a medium effect if V is bigger than 0.300. Call it a large effect if V is bigger than 0.500. Now, what was V in our case again? In our analysis, V was equal to 0.25. So, according to Cohen's benchmarks, we can interpret it as a small effect. Our obtained value of V was 0.25. It's bigger than his cutoff for a small effect, but not bigger than his cutoff for a medium effect. So we'll call it a small effect. We continue. I'm at the top of page 35. We've done the analysis. We have interpreted the analysis. The only thing that remains is writing up the analysis, summarizing the results of the analysis. The results of these analyses are reported in the following section. Call-out numbers such as 1 have been added to specific locations to identify information that will be explained in greater detail in the following excerpt. So here is my sample write-up for the chi-square test. Begin with describing what was done. Present a figure that reports percentages within gender. This paragraph gives us results from the null hypothesis significance test, as well as the index of effect size. Let's continue. I'm on page 36 now. Halfway down page 36, I have diagrammed the statistical results. In the preceding excerpt, we use the following sentence to report results from the null hypothesis significance test. It says, chi-square test for independence revealed statistically significant relationship between participant gender and team and exercise status. Chi-square of 2 degrees freedom, sample size is 238, chi-square was 15.34, p is less than 0.001. Once again, here are the statistics that appeared at the end of the preceding sentence. Call-out numbers such as 4 have been added to identify the 4 specific statistics that will be discussed in greater detail below. I have diagrammed the statistics related to the null hypothesis significance test, and for most of these, I've added a call-out number that indicates where you need to look in the Jamovi output in order to find the statistic. It begins with a symbol for the chi-square statistic, and then within parentheses, we begin with the number 2. You've heard me say that in APA style, the number within parentheses is usually degrees of freedom, and that's the case here. Now, where am I supposed to find degrees of freedom? Well, apparently Hatcher has used the call-out number 4 to identify it. Is that true? It is true. When you look at the part of the Jamovi results headed chi-square test, degrees of freedom, call-out number 4, the degrees of freedom were equal to 2. That's where that 2 comes from. Let's go back to our diagram results. The next, uppercase N is equal to 238. You know that in APA style, uppercase N usually refers to the total sample size. So this says total sample size is 238. Where am I supposed to find that in Jamovi results? Look for call-out number 5. Call-out number 5 is sample size, and there it is, 238. We continue with the diagrammed results. The chi-square statistic itself was 15.34. That's the obtained value for the chi-square statistic. I used call-out number 6 to indicate where you can find it in Jamovi results. Let's see. Call-out number 6, obtained value for the chi-square statistic, right there, 15.34. We continue with our diagrammed results. Finally, p is less than 0.01. That's my obtained probability value. I use call-out number 7. And sure enough, in the chi-square test output, call-out number 7 is my obtained probability value for the chi-square statistic. So here I have diagrammed it. This text just refers to the table that I have referred to, where we found all the statistics we needed in reporting results from the null hypothesis significance test. There's still index of effect size. How do I report that? Where do I find it? I'm at the bottom of page 37. Kramer's V for the current analysis. As an index of effect size, Kramer's V was computed as V is equal to 0.25. For a 2x3 cross-tabulation table, such as the one analyzed here, this constitutes a small effect according to Cohen's criteria. The requested statistics appear in this table that was headed nominal, produced by Jamovi. Obtained value of Kramer's V appears in the preceding table at the location where the row headed Kramer's V intersects with a column headed value. Table shows that the obtained value for Kramer's V was 0.25. Sure enough, Kramer's V, 0.25. Okay, this has been a long chapter and a long video. Summary of analyses of these results. Yes, this has been a long chapter. Let's step back and refresh our memory on why we did these analyses and what we found out. Given the length of the video, I'm not going to go over all of these sections. I leave it to the interested reader to go over this summary and refresh your memory on why we did the analyses we did, what do the various results mean in summary. That brings me to page 39 and a red font box that says, end of the material needed for the current exercise and related multiple choice quiz. This has been your whirlwind introduction to one of the most frequently reported statistics in the social and behavioral sciences. This has been video covering lecture notes for chapter 070, chi-square test for independent samples.